Hi, my name is Maike. I'm an engineer, CEO, and co-founder of Cyclize. With Cyclize, we're enabling circular economy of carbon. And that is important because, as you all know, with plastics and the chemical industry in general, we rely on carbon. Carbon atom is the key of producing all the lovely products we use in our daily life. But today we are in a linear use of this carbon. So we take the fossils, we convert them into, for example, syngas. So syngas is a basic building block of the chemical industry. It's a mixture of carbon monoxide and hydrogen, and it goes into many different value chains to produce a lot of different products. Along this linear use of the carbon, we lose all the carbon into CO2 in the atmosphere. And that's a pity. So it's kind of obvious that it's a great idea to bring this circular use of carbon into a circular economy and really keep the carbon atoms in the loop. Cyclize is doing that by converting waste and CO2 back into syngas. So we are replacing the incineration and we are replacing the fossil feedstocks. But the process itself, the value chain, can stay like it is. And this process can be repeated over and over. And that's because we are working on an atom level. And the atom itself, you can never destroy. So you can repeat it and repeat it and repeat it. How does this work? Well, the technology starts with mixed waste. This can be basically anything that contains carbon. So it can be biomass, but it of course also can be plastic waste. And this mixed waste goes into our plasma reactor together with CO2 and steam. That's important to be able to balance the inhomogeneous feedstock. The process itself is run electrical, so we use electrical energy to create a plasma. And the plasma is reforming the atoms and molecules into syngas. You can imagine plasma like a molecule chipper. So it's shredding down the molecules and reorganizing them into carbon monoxide and hydrogen. So the product we're producing is very pure and easy for a drop-in use in the existing value chain. Here I brought you the waste examples we are most proud of. So we have tested a lot of different waste streams, and I brought all of them today here as a sample. So on the left-hand side, you can see liquid residuals from plastic production, for example. Usually quite ugly and toxic, hard to recycle. Usually it goes into specific or special incineration plants. Then we have shredded cars, a broad mixture of different types of textiles, foams, cables, plastic layers, glues, all together. Then we have insulation foams, which usually comes with a lot of adhesives, which are also hard to handle from a recycling perspective. Then we have typical household waste, which is really everything we throw in our bin at home. And we have post-consumer shoes, which we can recycle as well. It's quite difficult because it's all mixed together, it's glued, it's sticked, it's hard to separate. That's why it's interesting to use a very robust technology like the Cyclize ones. And this is how plasma looks like. We can recover the carbon from any kind of waste, and the recovery rate we usually generate is above 90%. So if you want to test your products, how high the recovery rate we can achieve with Cyclize, we can test it in our pilot plant. This plant is running in Stuttgart, and we can test a lot of different samples here to prove that it's recyclable and the carbon is going back into the loop. And with this, I would like to invite you to be part of the transformation for carbon circularity, redesigned by engineers, not by slogans. Thank you.